In this graph, and that's probably close, I'm going to get to the actual one in the software. Can you tell me what the domain and the range for each one, for f and for g? Let's begin with f. Your domain. Your domain is the x value, and your range is the y value. Now, where's the x value for the f? The f is the straight line. The x value for that goes from where? From this value here, which is this value, all the way to where? To this number. To this one. From this, because that's including that point, from this value to this value. So what is the lowest value here? 1, 2, 3. Is that negative 4? All the way to what? To 4? Is the negative 4 included? It's a closed circle. Yes. Is that one included? Yes. From negative 4 to 4.
If it was an open circle, what would it be?
That would be parentheses instead of square brackets. The range is the y value. What is the smallest y value that you see for f? It's this value. Right here. And what's the largest y value for f? It's this one. So your range is from this number to that number. That's where the y value is. What's this number? Negative 3. And what's that number? 5. Let's look at the g function, the domain, and the range. Now, maybe I'll use a different color for that. I'll use red for it. Now, the x value, it looks like it's the same one. The domain from this value, which is a negative 4, to where? So the domain is from here to here, still negative 4 to 4. And where's the range from? The range is a little bit different now. From this y value to this y value. From here to there, which is what? Negative 4 to 4. So what's the domain for f? Negative 4 to 4. What is the range for f? Negative 3 to 5. What is the domain for g? Negative 4 to 4. What is the range for g? Negative 4 to 4 again. Couple more questions. It says, can you tell me what f of 2 and g sub 3? What is f of 2 equal to? And what is g sub 3 equal to? F of 2, this is the f function. When x is 2, what's the y value? 1, 2, 3. See, x is 2, you go up 3 units. Except I'm going to look at the real picture on the website just to make sure. When it's 2, it does look like it's 3.
That was my question. Is there like a formula for that?
No, you're going to just look at the picture.
You just get graph
Yep,
and do it like
yep. You're going to look at the picture. You go, when it's 2, what's that number? This is 2 here. Because you don't know what the... You could find the equation for it.
Yeah.
So what's the y value here? 1, 2, 3. So based on my picture, f of 2 is actually a 3. What's g sub 3? This is when it's 3. What's the y value? Based on my picture, that's what? Negative 1. Because it's this number. Or this number. The graph actually is more steep. For the 3, it looks like actually a -2. Their graph's steeper than mine. So if you look at their graph, that might look like a -2 on their graph. So when I plug it in, I'm going to put the -2. But for this picture, the way I drew it, it looks like a -1.
This seems pretty kind of like guessy.
Yeah, well, you got to eyeball it.
Especially for this
Yep.
program.
3, -2. What value of x, f of x equals g sub x? Where they cross each other? F of x equals g sub x, isn't it right there? And this is what, -1? Can you tell me when g sub x is 0? Where? Only g sub x. It looks like right here. It looks like right here and right here. So let me look at their picture, which is, I'll be more accurate with their picture. It looks like the -1, the 1, and the 2. They have 3 boxes. -1 goes in the first one, the smallest value. 1 is the next value, and the largest value is what, 2? When do you submit?
You have to just submit your answer with the whole assignment.
When you do the whole thing, all the problems?
No, you can submit them one by one.
Doesn't show submit there, so I'll look
You have
later.
to like screw around. Sometimes it doesn't pop up.
Yeah.
Sometimes like the show not an example doesn't pop up either. It's weird.
Well, this machine especially is a piece of junk, so. But these are the answers for that one. So they're looking for the intercept, the x-intercept for g, -1, 1, really 2 here. Yeah. So that's actually in the first one, number 1. Looking at the picture and answering the question. Hopefully no graph for the rest of them. Let's look at number 4. Number 4. We have f of x, again, mine is different than yours, 9 cosine 2x. The question, what is f of 0? 9 cosine, what is 2 times 0? 0. X is 0. Now you need to have the unit circle handy somewhere. You can go to Google and just write unit circle and pick any one that you like. I picked one in color there. Cosine of 0. Cosine is the second number, cosine is the first number, sine is the second number. What is cosine of 0 equal to? 1. See it from that picture? So this will be 9 times 1, which is 9. So what is f of 0? That's a 9. The next one, what's f of negative pi over 4? That would be 9 cosine. Take this number and multiply it by 2. What is 2 times negative pi over 4? If you divide the top and the bottom by 2, this is 1, by 2, this is 2. That's negative pi over 2. Negative, you're traveling clockwise. 90 degrees. Pi over 2 is 90 degrees. Let me look at my unit circle. Clockwise, I'm traveling this way. This is pi over 2. What's the cosine of that? 0. So 9 times 0, which is 0. If you don't have a unit circle, you could actually plug it into your calculator, it will give you a 0. And the last one, what's f of pi over 3? This will be 9 cosine 2 times pi over 3, which is 9 cosine 2 pi over 3. And if they're looking for the exact answer, you better use the unit circle, because, well, actually in this case you'll be okay. This is pi over 3, 2 pi over 3, you see it? What's the cosine of that? Negative 1/2. So 9 times a negative 1/2, that's not negative 9 over 2, or negative 4.5. You can put either one because they're both exact.
It allows decimals?
Well, it's exact when you divide them. If it was 1/3 and you put 0.33, that's not exact. But the fact this is exact, negative 9 over 2 is the same as 4.5 on the money, it will take either one. Unless it says write your answer as a fraction. It says simplify the result, and that's simplified. Negative 9 over 2 or negative 4.5, those exactly the same. But if it was 1/3 and 0.33, they're not the same. That's a rounding. So that's the answer to number 4. Okay.
Number 5.
Number 5.
Even my Wolfram Alpha calculator, I put the answer in for that. That still was.
You don't need it.
I don't need it, but I want to see if it would accept that answer. It didn't.
The question is, given that, what is f of x plus delta x minus f of x divided by delta x? Delta x can't be 0, obviously. Well, I need to find what this one is. I have no idea what this one is. But once I find the answer to it, I'm going to subtract from it what? F of x, which is what? X cubed. And take the result and divide it by what? Delta x. So I know this and I know that. This is the only thing that I don't know the answer to. Well, how do you get the answer to that? Well, f of x plus delta x, it says go to the f function, which is this one, and replace x with what? With delta x, and don't forget to cube it. So what's that mean? It means x plus delta x times what? X plus delta x times x plus delta x. 3 times. If I multiply the last two and simplify the answer, that's x squared plus the FOIL method, 2x times delta x plus delta x squared. The FOIL method. And now you got to take this one, multiply it by all 3 of them, and when you're done, take delta x, multiply it by all 3 of them, and collect like terms. What is x times x squared? X cubed This will be 2x squared delta x plus x delta x. What's delta x times x squared? X squared delta x. What's delta x times 2x delta x? 2x delta x squared. And finally, delta x times delta x squared is delta x cubed. Clean like terms. Notice this one and this are the same type. We can put them together. 2 and 1 is what? Oh, that's cube. Yep. Is that what you wanted to say?
Yes.
Yep, thank you. This will be 3x squared delta x plus 2x delta x, oh, and plus 1 here, right? These two are, oh no, they're not the same. They're not the same. I thought they were, but they're not. 2x delta x squared plus what? X delta x. This was okay, actually. This is the one I want. Plus what? Delta x cubed. Now put that in here, and let's simplify it. So let's go back to the top. We say if we know what the answer to this, we should be okay. Well, now we know the answer to this. X cubed plus 3x squared delta x plus 2x delta x squared plus x delta x plus delta x cubed minus x cubed over delta x. Notice that x cubed will cancel the x cubed. And every one of these has what in it? Delta x, right? So if I factor out delta x, what's left in it? 3x squared plus 2x delta x plus x plus delta x what? Squared divided by the delta x, and the delta x will cancel each other out. And if you write that in descending power, I can say 3x squared plus the x, and I'll increase the delta x power. And that'll be the answer to that one. I didn't like to multiply this 3 times, by the way. What about this 4 times? I don't, that wasn't that bad and still looked ugly to do this. There's a shortcut. I know we covered that. People who took tech math with me. It's called Pascal Triangle. Remember Pascal Triangle? I'll come. I'm going to show you how to get the answer to that quickly using the Pascal Triangle. And the Pascal Triangle starts with having 3 ones. Start with that. What's 1 plus 1? 2, right? 1's on the outside. Always 1's on the outside. What's 1 plus 2? 3. What's 2 plus 1? 3. 1's on the outside. What's 1 plus 3? 4. What's 3 plus 3? 6. 3 plus 1? 4. 1's on the outside. 1 plus 4? 5. 4 plus 6? 10. 6 plus 4? 10, 4 plus 1, 5, 1's on the outside. And you keep going as far as you want to. How is that going to help me finding the answer? You had x plus delta x to the third. The power is 3. This is when the power is 0. This line, line 2, when the power is 1. This line when the power is 2. We're going to use these numbers when the power is 3. We're going to use these numbers when the power is 4. We're going to use these numbers when the power is 5. Our power was what? 3? So what are my numbers? 1, 3, 3, and 1. See them? 1, 3, 3, and 1. Watch how quick they answer. 1, 3, 3, 1. There's a plus sign between them. And you're going to start with the first one raised to the power 3. And the second one raised to the power of 0. So you always start with the first thing here raised to the power, whatever that power is, and this one to 0. After that, each one of these, you decrease this power by 1, you increase that by 1. Let's decrease the power of x by 1. This becomes what? X to what power? 2. Delta x to what power? 1. The next one, decrease the power of x by 1. That becomes what? 1. Delta x to what power? 2. The last one, x to the 0. Delta x to what power? 3. What's delta anything to the 0 power? 1. 1 times 1 is 1. That's x to the third. What's delta x? 1. 1 times 3. 3x squared. Let's look at this. This will be what? 3x delta x squared.
What about the delta x in second row?
What? 3x squared. Oh, I forgot the delta x. Thank you. 3x delta x squared. And the last one is what? Delta x to the third.
I didn't even think about that.
Huh?
I didn't even think about the use the triangle.
Now, if this was, for example, to make it even worse,
So much easier.
I'll use h instead of delta x, because delta x bugs me 2 letters. If this was, I'll give you this, 2x plus, or let's make it even a minus, minus 3y to the power of 5. This is 2x plus a negative 3y, the whole thing like this, to what power? 5. Works when it's addition there. Now, the power of 5, the number is going to be what? 1, 5, 10, 10, 5, and 1. Start with the first one raised to the 5th power. 2x to the 5th. Negative 3y to what power? 0. Plus 2x to what power now? Fourth, negative 3y to what power? 1 plus 2x to what power? Third, negative 3y to what power? Squared. Plus 2x to the power of 2, negative 3y to what power? 3. Plus 2x to what power? 0. Oh, not the 0, 1, right? 1. Negative 3y to what power? 4. Plus, there's the 1 here. 2x to the power of 0. Negative 3y to what power? 5. And now let's simplify it. This is 1, that's 2x to the 5th. The whole thing to the 5th like this. We're going to simplify it more. Oh, instead of, and what's that equal to? What's 2 to the 5th? 32x to the 5th. Let's see what the next one is. 5 times. What is 2x to the 4th? That's 2 to the 4th. What's 2 to the 4th? 16x to the 4th. What's negative 3y to the first power? Negative 3y. I didn't bring a calculator. Let me see if I have one here actually. What's 5 times 16 times a negative 3? Negative 240. So instead of a plus, this would be a minus now. 240 x to the 4th y. The next one, 10, what is 2x cubed? That's 8x to the 3rd times, this will be 9y squared. This will be a positive. 8 times 9, 72, and 10, 720 x to the 3rd y squared. The next one, the next 10, that's 4x squared, and that's a negative 27y to the 3rd, I think. This will be a minus. A 1080 x squared y to the 3rd. The next one is going to be 5 times 2x 81y to the 4th. That will be a plus 8 times 81. Oh, 10 times 81, right? 810. And the last one is going to be minus, what is 3 to the 5th power? Is that 243? Y to the 5th. I'm almost positive if I did the FOIL method or multiply these 5 times, I'll get the wrong answer. I don't care how careful I am. I'll miss something. I'll miss a sign. So this is a nicer way of finding the answer to anything to the power. It's called the Pascal Triangle.
I wish I learned this in tech math that I took. Maybe I was like sick the day that was taught.
I know in my class we covered it. In tech math too. The last chapter. Yep. Yep. The last piece we covered.
Finally, there was like 4 of these,
Yep.
and they were all to like the 6 of it.
Yeah, 5, 6 powers, 7 power. You can just keep going as far as you want to. Just a nice, quick way to get to the answer. You know. You'll never see me do x plus delta x cubed because I know I will make a mistake, even for a cube. I'll miss a delta x, I'll forget the square, I'll miss something. I always end up with the wrong answer. So I always go to Pascal Triangle and get it that way. So take advantage of that.
We can print one of those out with a whole triangle for the test, right?
I don't think there's anything on the web. You can just make them. Start with the 1, 1, 1. That's it.
Yeah, I mean, like just bring in like a handout.
Yeah, you can make it. Takes 2 seconds.
Call me lazy.
Number 6. F of x equals 1 over the square root of x. I don't know if this is 19. Yeah, I think it's 19. It says, given this function, can you tell me, find f of x minus f of 3 all divided, of 20, not 3, I don't know where the 3 came from, 20. Divided by x minus 20. The bottom is just x minus 20. F of x is 1 over the square root of what? X minus 19. That's what f of x is given to us. Minus, what is f of 20? Go to this, replace x by 20. So what are you going to have? 1. Place x by 20. 20 minus 19 is what? 1. The square root of 1 is 1. 1 over that is 1. And now the question is, simplify this. First you get a fraction there. See the x minus 19 in the bottom? How about if I multiply the top of this equation, I mean not the equation, the fraction, and the bottom multiplied by the square root of x minus 19. Just to get rid of the fractions. What would you have? Square root of x minus 19 times this one, that's a 1. 1 times that, that's the square root of x minus 19. Over x minus 20 times the square root of x minus 19. Evaluate, if possible, the function. Yep, okay. Simplify the result. Simplify the result. Now, to me, I know in math we don't like to see a square root in the bottom. That's always like a no-no for us in math. So how do we rationalize that when you see a square root in the bottom? Multiply the top and the bottom by the square root of x minus 19. So what are you going to have? You will have the square root of x minus 19 times 1 minus the square root of x minus 19 divided by what? X minus 20. What is the square root of x minus 19 times the square root of x minus 19? X minus 19. I'm not sure if they want to stop here or not. This is called rationalize the denominator. Which means I don't want to see a square root in the bottom. That's really what that's called. Get rid of the square root in the bottom there. So on the top, we don't care about it. So if you want to distribute that, multiply it through this times this and this times that, You could rewrite that the square root of x minus 19 minus what? X minus 19, like this, if you don't want to leave it the way it is. For those people thinking about canceling the x minus 19, think twice. Can't cancel this with that. That's a subtraction. It has to be a multiplications. So notice in the bottom we have no square roots. Every once in a while, and I don't know if this book says that or not, or the homework, you end up with an answer like this, but instead of saying rationalize the denominator, they might say rationalize the numerator, the top. Just want to make sure you remember how to do that. I'll go back to it. I was right here. I'm not sure why they'll say that, but let's say the problem says rationalize here. The numerator there. Instead of the denominator, they said we don't want to see a square root on the top. How would you get rid of that? Very good. What is that called? Yep, very good. Conjugate. Multiply by 1 plus. Change the sign. This is called a conjugate. We switch the sign. We make it a plus. So you'll have, on the top, you'll have 1 minus. You'll see in a second why we switch the sign. This would be a lot more work if they said rationalize the numerator there. The FOIL method, if you look at the top, I'll show you why we switch the sign. What's 1 times 1? 1. Then that'll give me a plus the square root of x minus 19. This will give me minus the square root of x minus 19. When you multiply this by that, that'll give me minus what? X minus 19. And notice what happens to these two. They cancel each other out. So what are you going to have? 1 minus x, and this becomes what? Plus 19. What's 1 plus 19? 20 minus x on the top. Let's look at the bottom. The bottom, x minus 20. Maybe I can multiply the last two. This times that will be what? X minus 19, the square root of that, plus this times that, which is what? If I take the minus sign out, that should be what? Plus, right? Because it's minus x. Why did I switch the sign? What was I thinking about? Where is it? Oh, right here. I'm sorry. Oh, my mistake. Yeah, I'm looking right here. I was looking at this and this. This times this, that's good. This times that's x minus 19. That's correct, yeah. Can I cancel anything? Look at these two. Except what? Aren't they opposite? So better be a minus 1 there. So it's negative 1 over x minus 19. I'll put that first. Plus the square root of x minus 19. Or I could have left it like this. This times that if I want to. You know?
Wait, that's a rule? You can cancel.
Yeah, if they're backward and you cancel them, it's always a minus 1.
Sweet.
Yep. The reason it's a minus 1.
Less than you just gave an answer.
Yep. The reason that's a minus 1, the question, why is that a minus 1? Pick any two numbers you want. Any two numbers. Big, small, doesn't matter.
3,
Huh?
3,
3 and give me another number.
7,
7? 3 minus 7 over 7 minus 3. What's 3 minus 7? What's 7 minus 3? 4. What's negative 4 over 4? Negative 1. Anything you want, any numbers. It's going to be a minus 1 always when you switch them. So that's why these guys can cancel each other out, and the result's always a minus 1.
See, let me get that paper real quick. I was listening to that. Thank you.
Yep. And let me look at 9, the last one on this section. F of x equals x squared, and I think mine is negative 7. And this one, find the domain and the range, and that's it. Think. 9, yep. Find the domain, find the range. Well, if I graph that, we know what x squared looks like. We did a lot of graph with plain x squared. It looks like this. And it keeps going. What's x squared minus 7 will be? That's vertical shift by how many units? 7 down. So if you shift that graph 7 units down, it's going to look like this. So this is x squared minus 7. And it keeps going. It doesn't stop there. That's what the arrow is telling you. It keeps going. So what is my domain? Where's the x value going? From where to where?
All real numbers.
Yep. The domain is from negative infinity all the way to infinity. You can't reach infinity. That's why you have parentheses. From this end to that end. All the values. And where's the range going? From where to where?
Negative 7 from infinity.
Is the negative 7 included?
Yep.
So from negative 7, including that, all the way to infinity. And that's number 9.